Hi students, so welcome back to another lecture of current electricity. Till the last session we have covered circuit basics, then some sessions were there about cells in detail, internal resistance, EMF, terminal potential difference, terminal voltage, discussing all this. So today again we are coming back to cells to discuss about grouping of cells. The cells can be connected in series or in parallel or series parallel combination, all these. So we will be discussing about that today. So when you connect in series, what is the equivalent EMF? When you connect in parallel, what is the equivalent EMF? Which is the better configuration in order to get maximum current from the combination? So all these things we can discuss today. Okay, so first we will start with the cells in series. Cells in series. So a cell, its internal resistance, another cell, another internal resistance. Likewise, we are taking three cells just for understanding purpose: R2, E2, R3, E3, likewise R3, E3, likewise. Now suppose if we replace this combination with its equivalent resistance, internal resistance equivalent, and suppose if we replace these three cells or batteries with a single battery of equivalent EMF, okay, then what will be the equivalent EMF and what will be the equivalent resistance? This is what we are taking into discussion today. Now we know, suppose current I, this is series connection, so current I will be flowing, okay. So same current must be flowing here also, because this is same combination, equivalent, we are replacing with equivalent. Now just like we have done in while studying Kirchhoff's law, from one terminal to another terminal, when current flows, what happens? Okay, just we will mark in the direction of current plus minus, plus minus, plus minus, here plus minus. If this terminal if we consider as A and this terminal if we consider as B, okay, A, B, okay. Now we will find the potential difference between terminal A and terminal B. So how we have done that? We will choose a path we can choose in that way or this way, it's our wish. Okay, so now minus IR1 plus minus, so minus plus, so E1, it's our wish in whichever way we can take, but we need to stick to one sign convention to avoid confusion. So minus IR2 plus E2 minus IR3 plus E3 minus VB is equal to 0. So here VA, okay. So VA minus VB, whatever difference is there, that will be in between these two terminals. So I can write VA minus VB is equal to IR1 minus E1 plus IR2 minus E2 plus IR3 minus E3. Clear? So here VA minus VB, if we take I outside, we can write I into R1 plus R2 plus R3 minus if we take outside, we can write E1 plus E2 plus E3. Okay, is it clear? Now this side, how we will write? So here, okay, I am writing VA minus IR equivalent plus E equivalent minus VB is equal to 0. So here VA minus VB is equal to, this goes to that side, IR equivalent minus E equivalent. Okay, so left hand side of both are same. Left hand side of both are same. Okay, now, so you have seen this, everything is clear. I am erasing this. So this side, okay, equation 1, equation 2. So LHS is same, so I am equating both. So I into R1 plus R2 plus R3 minus E1 plus E2 plus E3 is equal to IR equivalent minus E equivalent. So compare this, okay, comparing this, what we can understand, R equivalent is nothing but R1 plus R2 plus R3, and the equivalent EMF is going to be E1 plus E2 plus E3. Okay, so what we are understanding from here is, if cells are connected in series and if they are in same polarity, simply we can add them, and obviously internal resistance we can add if they are in series. So when cells are connected in series, this is how we will get the internal resistance equivalent and the EMF equivalent. Clear? Note it down. Suppose if we reverse the polarity, now in the previous case you can notice that all the cells are in the correct order, that is their polarities are same, minus to plus, minus to plus, minus to plus. Suppose if we connect two cells like this and the third cell in the opposite polarity, if this is A, this is B, then R1, E1, R2, E2, E3, R3. So see, these polarities are different. Now what will happen? E equivalent is going to be E1 plus E2 minus E3. R equivalent, what will happen? Even if we change the polarity of cell, resistance doesn't have any effect. So this is going to be R1 plus R2 plus R3. Okay, so if the polarity is changed, then EMF will have its difference. So this one also, just like in the previous case, we can have VA minus IR1, same steps you can follow, you will be getting this relation. Okay, same thing. So if the polarity changes, how this is going to affect? Now listen here students, suppose if 5 cells are there, okay, 5 cells are there, 3 cells are connected in same polarity, 2 cells are connected in the opposite polarity of these 3 cells. Now what will be the effective EMF in that case? Some of the students may say, okay, 5 are there totally, so 2 is connected in the opposite order, then 5 minus 2, so 3 is the effective EMF. So it is not so, that is wrong. Just see. 5 cells are there. Okay, I am taking the same example. Okay, 1, 2, 3. They are in the same polarity. Now, this is reversed. Okay, so A and this is B. So E1, E2, E3, E4, E5. Now all these E1, E2, E3, E4, E5 all are same EMF. Say for example E. Okay, E1, E2, E3 all are same. So we'll mark like that. Okay, E5, E4, all these things we'll remove. Okay, they are all with the same EMF E. Now what will be the effective EMF? Okay, so if we think like total is 5, 2 are reversed. If we try to write E5 minus 3 is equal to 2, this is wrong. Okay, see, this EMF and this will cancel the EMF effect of this one. This will cancel the EMF effect of this one. So effective EMF is going to be just E. Okay, this will nullify the effect of this will nullify the effect of this, or these two will nullify the effect of 2. Okay, then remaining only 1 will be there. So this is how we should handle them. Okay, we will do some problems. Take this question, 4 volt, 3 volt, 1 volt, and their internal resistances are given. One external resistance is also given. What is the current through ammeter? So what is the current through ammeter? So we can solve this problem, okay, in various methods. So one method is just taking the effective EMF, effective resistance, draw a new circuit, then solving it. So how can we take this, which are all in same polarity? 4 volt and this 1 volt, they are in same polarity. So this is opposite polarity. So effective EMF is nothing but 4 plus 1, they are at same polarity. Okay, so this is in the opposite polarity, correct, minus 3. So this is going to be 2 volt. What is R effective? these three we can add. This will become 1 plus 0.5 plus 0.5 is equal to 2 ohm. So how we can redraw this circuit? We can redraw the circuit in this way. This is E effective, which is nothing but 2 volt, and this is its internal resistance 2 ohm. Then this is 4 ohm. Okay, what is the reading through ammeter means nothing but what is the current through this circuit. This is just a ideal ammeter. Practical ammeter we will learn this as a separate topic. Okay, this is nothing related to ammeter concepts will come here, just we need to find the current. So now this is the new circuit. Now how we can put this current will be flowing in this direction, either direction we can take, no problem, we'll get the answer. So plus minus we can take. So here again 2 minus I into 2 minus I into 4 is equal to 0. So 2 minus this will become 6I is equal to 0. 2 is equal to 6I. I is nothing but 2 by 6, or we can say 1 by 3 ampere. So we are getting 1 by 3 ampere. I have put an option 1 by 3 ampere because answer was not there in the option when I gave. Now I have added one options, but this is the answer. Okay, clear? So simply this is nothing but E effective. Okay, see, I is equal to V by R equivalent. So V is nothing but 2 here, and R equivalent is nothing but, this is series, simply we can write 6. So this is just by solving using the basics of series of cells. Clear? Now otherwise if we want, we can, without doing this cell basics, simply we can apply KVL and find. Okay, simply we can apply KVL and find. Just put a loop like this directly. Okay, so plus minus plus minus plus minus plus minus. I am assuming that current is flowing in this way. So 4 minus 0.5 I minus 3 minus I, this one, then minus 1 into minus 1 minus 0.5 I, then minus 4I is equal to 0. So solving this we will be getting answer. So 4 minus 3, this is plus 1. Okay, so 5 minus 3, 2 minus 0.5 plus 0.5, 1 plus 1 is equal to 2, then minus 6I. Minus 6I is equal to 0. So 2 is equal to 6I, I is equal to 2 by 6, which is nothing but 1 by 3 ampere. So directly also we can do, or just by replacing with the cell circuit. Now n cells of EMF E and internal resistance R. Okay, so suppose if we connect n number of cells with the same EMF E, likewise n times. Okay, this is nth, first, second, third, up to how many? N. So this is R, again R. Okay, fine. And this is external resistance R. So E equivalent is nothing but E1 plus E2 plus E3. So E plus how many? Up to N. So this is nothing but E equivalent is nothing but NE. Okay, if they, since they are in the same magnitude, we can write NE. Same way, R equivalent is R plus up to how many R? N times N R's. Then NR equivalent is nothing but NR. So this is the equivalent EMF and this is the equivalent resistance. Now, what will be the value of current? So value of current is nothing but I is equal to V by R equivalent. So I is equal to E equivalent divided by what is total R equivalent? R equivalent, this one plus this external resistance R. So we can write NR plus R. NR plus R. So that we will substitute here. NR plus R. So I will become NE divided by NR plus R. So when there are n number of cells with the same EMF, okay, and internal resistances, when it is connected to any external circuit or any external resistance, we will be getting the current as I is equal to NE by NR plus R. Okay, note it down. Suppose if this external resistance, if it is very much less than the equivalent internal resistance, suppose if we are connecting a resistance to the circuit and if that resistance is very much less than the internal resistance, in that case what can we do? I is equal to NE divided by, this is going to be like NR, neglecting this R. So I is equal to E by R. So this is just like that is, if external resistance is very much less than the combination of resistances, then the current will be like a current from a single cell. Okay, like the current from a single cell. Okay, now suppose if R is very much greater than NR, then what will happen? I is equal to, if this is the condition, I is equal to NE by R. We can neglect this one, this is very small. Now this is nothing but N into E by R, right? N into E by R. So this is like N times the current from a single cell. Okay, the current will be passing through external circuit. So this is just like a current that is coming from N number of cells. Okay, that will be the effect. So suppose if we need maximum current, okay, if the external resistance is very much greater than the combination of internal resistances, if external resistance is very much greater than the combination of internal resistances, then if we need high value of current, we must connect the cells in series so that we will be getting just like a current which is equal to n times the normal current or current from a single cell. Clear? Now I mentioned that when we connect cells in series and some cells are connected with opposite polarity, okay, what will be the effective EMF? Already we have mentioned, but there are total n cells and m cells are reversed. So we can write equivalent EMF is nothing but n minus 2m into E. Suppose all these cells have EMF E. Okay, all the cells are of EMF E. Just two cells polarities are reversed. So equivalent EMF is nothing but n minus 2m into E. Suppose 5 cells are there. 5 cells are there. 2 cells reversed in a reverse manner connected. So suppose 3 cells are in this form, 2 cells are connected like this. This is E, 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 E. So these are reversed. So what will happen? This one will neglect or nullify the effect of this one, this one, this one. So finally what will happen? There will be only E. If we substitute here, this is nothing but totally 5. Reversed is 2. So 2 into 2 will be getting what? 1. So 1 is into E. So 1 E we will be getting, correct? So in this way we should not get confused and do the mistake. Okay, simple concept only, just for your sharpness I am telling. Okay. See this question, students. N identical cells, each of EMF 6 volt, connected in series with an external resistance of 5 ohm, carry a current of 10 ampere. Then, if polarity of one cell is reversed, the current is 8 ampere. So find number of cells and internal resistance of each cell. So n identical cells when connected, okay, n identical cells when it is connected in the same polarity, equivalent EMF is going to be Ne, and equivalent internal resistance is also Nr, and what will be I? Current is going to be V by R equivalent. External resistance 5 ohm is also there. So suppose equivalent EMF, if we consider as Ne and internal resistance as Nr, then there will be an external resistance which is nothing but 5 ohm if we connect, and this is nothing but 6N. Okay, this is the setup. Now I is equal to V by R, V divided by the combination of these two resistances, which is nothing but 6N, or I will write Ne divided by what? Nr plus external resistance R. So this is nothing but I is equal to N is, we do not know, 6, EMF is 6. So 6N divided by, this is also given as 10 ampere. NR plus 5. So cross multiplying, we will be getting 10 NR plus 50 is equal to 6N. So if we rearrange, we can write in this way, 6N minus 10 NR is equal to 50. So let it be equation number 1. Now, okay, copy this. I am erasing this. One polarity of one cell is reversed, the current is 8 ampere. That is the data we require now. Polarity of one cell is reversed, and now the current becomes 8 ampere. So what happens when polarity of one cell is reversed? Okay, now the equivalent EMF will be what? N minus 2M into E. So equivalent EMF is nothing but N minus 2M is nothing but 2 into 1 into what is the EMF? 6. So this time equivalent EMF is nothing but N minus 2 into R, and R equivalent no change, this is NR itself, and external resistance R is 5 ohm. Now here new circuit is like this. Only change here is this is NR, this is 5 ohm which is R, and this is 6 into N minus 2, 6 into N minus 2, and the current which is passing is 8 ampere. Here the current passing was 10 ampere. So I is equal to V by R equivalent. So 8 is equal to 6 into N minus 2 divided by NR plus 5. So we will be getting 8 NR plus 40, 8 NR plus 40 is equal to 6N minus 12. Correct? So what we will do according to this equation, yeah, just like this we will rearrange. So we can write 6N just like this. 6N, this will go to that side. 8 NR is equal to 6N minus 8 NR is equal to 12 will come to this side. This is going to be 52. Okay, two equations we got. Clear? Copy this. Okay. Right. So 6N minus 10NR is equal to 50, one equation. 6N minus 8NR is equal to 52, another equation. Okay, so 1 minus 2 if we do, we will be getting minus 2NR is equal to minus 2. So NR is equal to 1. NR is equal to 1. So this NR we can substitute in any of the equations. So we will substitute in 1. So in 1, 6N minus 10 into 1, NR is equal to 1 is equal to 50. So 6N is equal to 60 and N we get as 10. So number of cells is equal to 10 we get. NR is equal to 1. NR is equal to 1. Sorry, 1. So we get 10 no as N. So 10 R is equal to 1 and R we get as 0.1 ohm. Okay. So 10 and 0.1, option D. Now next topic is parallel grouping of cells. We have arranged cells like series. Now we will set the cells in parallel and we will see what is the effect. So two cells we will take as parallel. Okay, two cells we will consider as parallel. Okay, so this terminal we consider as A, this terminal we consider as B. R1, E1, R2, E2. Okay, so suppose current I is coming. So this is divided into I1, I2. So going plus minus, I1 is coming. Okay, and here plus minus I2, and they will join, and that becomes I itself. Okay, right. So now our task is to find what is the equivalent EMF. Okay, what is the equivalent internal resistance? So how to find equivalent EMF? That is the priority here. Internal resistance, like how to find equivalent, we know. Now suppose if this circuit becomes like this is equivalent internal resistance, and this is nothing but the equivalent EMF. Okay, so same thing. Suppose if we convert this circuit into this form, then what we will have to substitute here, that is the idea. What current is flowing this circuit? I is what is flowing through the whole circuit. This is dividing here, so this is also going to be I, plus minus. Okay, so if this is terminal, that is terminal A, this is terminal A, and this is terminal B, we can consider this as terminal A, and again this as terminal B. Okay, now we will analyze them. So if we take path, okay, one case we will take this path, another case we will take this path also. Okay, so we will name this as, B is already here, so C, D. This can be named as X, Y. So path A, C, D, B. Okay, path A, C, D, B. Okay, so this is VA, potential is VA, minus I1 R1 plus minus, plus E1 minus VB. Correct? VA minus I1 R1, okay, plus E1 minus VB. Or we can say VA minus VB is equal to I1 R1 minus E1. Clear? Now next we will consider path AXY, B. Okay, so same way, VA minus I2 R2 plus E2 minus VB is equal to 0. So VA minus VB is equal to I2 R2 minus E2. Clear? That is a potential difference there. Now in this case, VA minus IR equivalent, and here again plus E equivalent minus VB is equal to 0. So VA minus VB is equal to IR equivalent minus E equivalent. Clear? Copy this, note it down. Okay, done. Now we will consider, now I am erasing this. Suppose if we consider VA minus VB as V, okay, the potential across this branch, and the other branch, all are same terminal. So if we consider VA minus VB as V, then I can write V is equal to I1 R1 minus E1. Same way, V is equal to I2 R2 minus E2, and V is equal to IR equivalent minus E equivalent. Okay, so from this I can find I1. I2, I3. So I1 is nothing but V plus E1 by R1. Here I2 is V plus E2 by R2, and here I is equal to V plus E equivalent divided by R equivalent. Clear? Okay, now what we know? We know I is equal to I1 plus I2. Just look at the figure in your note. It is I already raised in the board. So look at the figure. I is equal to I1 plus I2. Correct? No? I is equal to I1 plus I2. So I is what? V plus E equivalent divided by R equivalent is equal to what? V plus E1 divided by R1 plus V plus E2 divided by R2. Correct? V plus E1 by R2 plus V minus V plus E2 divided by R2. Now can we write in this form? V by R equivalent plus E by R equivalent is equal to V by R1 plus E1 by R1 plus V by R2 plus E2 by R2. Copy this. Now from there what we are going to do is V by R equivalent plus E equivalent by R equivalent is equal to, we will separate V and V by R1 plus V by R2 plus E1 by R1 plus E2 divided by R2. Now we can I will take this V outside. I will be getting 1 by R1 plus 1 by R2 plus E1 plus E2 R1 plus divided by R2. Clear? Now we just need to compare. Okay, we just need to compare the equation, what we are getting, what we are able to observe. V by R equivalent, we will compare this term and this term. Okay, the V terms we will compare. So this is equal to V into 1 by R1 plus 1 by R2. So V and V will get cancelled off. We will be getting 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Okay, so this is the R equivalent formula we can take. Okay, the comparing and segregating the V terms and E terms. Similarly, we can take E equivalent divided by R equivalent is equal to E by R1 plus E2 by R2. Correct or what? Okay, so here we can write E equivalent is equal to E1 by R1 plus E2 by R2. E2 by R2. So when you bring this to that side, we can put here 1 by R equivalent. Correct? This will go to numerator, that I can write like this also, 1 by R equivalent. So finally we will be able to write equivalent EMF. Equivalent EMF in parallel system of cell is E1 by R1 plus E2 by R2 divide by 1 by R1 plus 1 by R2. Clear? So this formula we can remember. Okay, if you remember this formula, it will be easy for us to solve many things. Clear? Okay, so equivalent resistance, internal resistance is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. And equivalent EMF is E1 by R1 plus E2 by R2 respectively. Suppose if we draw a circuit like this. If I reverse a polarity. Okay, so this is R1, this is E1, R2, this is E2, R3 and this is E3. Okay. So what is the equivalent EMF we can say? This is nothing but E1 by R1 minus E2 by R2. Why minus? Because polarity has been changed here. Plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So if polarity is changed, okay, this is how we need to deal. See, from which direction you are considering current, all these things depends on you. You can take in whichever direction we want, then we need to handle them carefully according to proper sign convention. That's it. If very much specifically given in the question, then we will have to follow that. We will do problems on this, then we will understand how to handle the situation. So okay students, so I am stopping the session today. We have studied series resistance and series internal resistance, series EMF or cells. If we connect in series, what will happen? We have studied E equivalent is E1 plus E2 plus, likewise if they are all same then NE. Internal resistance is nothing but R1 plus R2 plus up to Rn. If they are all same, this is nothing but NR. Parallel combination, this is the kind of formula we get for equivalent EMF. E1 by R1 plus E2 by R2 plus E3 by R3. One polarity is changed, we will have to change accordingly. 1 by R1 plus 1 by R2 plus 1 by R3. Now this is just an introduction about parallel set of cells. Now we will have to generalize them. Then we need to find for maximum current in parallel setup. Then we will do some problems. Then we will, next session we will finish with the mixed grouping of cells. Okay students, thank you, goodbye.